Hello, thanks for joining me. I'm JP Miller, and this is a high-level overview of object-oriented programming, specifically in the JavaScript language. So let's talk about object-oriented programming. To begin with, we need to define an object. So what's an object? An object is defined as a collection of related data and/or functionality. Think of objects as a chest of holding. Inside the chest, you can hold functions and variables. And because of the smorgasbord of data, we call objects composite data types. The building blocks of an object are called fields or properties. Now, you'll most likely hear me call these properties throughout the nanodegree. Properties can describe some aspect of an object, for example, a person's name, gender, or their interests. Objects are a cornerstone of the JavaScript language. Many built-in data types such as arrays, regular expressions, and functions are represented as objects in JavaScript. In order to be a successful JavaScript developer, you absolutely must have a firm grasp on how objects work. So, with that, let's begin and let's take a look at an example of an object. Here's an empty object. It's very simple. Create a var, assign a pair of curly braces to it, and you have created an object. Voila! Okay, now let's take a look at the populated object. This is called object literal notation. JavaScript provides us the syntax which allows us to quickly create objects. We could say that this object uses literal notation. If you're ever asked to write an object using literal notation, this is it right here, this var person, our person object. Inside the object, we see several key value pairs. The property on the left is the key, such as name, gender, interests. The string, number, object, or other data type on the right is known as the value. JP, male, improv. Thus, we call this the key value pair. Now, you'll also notice the indentation in the object, and this is very important to help understand the architecture of our code. Most modern text editors will help you automate your indentation, and there are other tools online and tools that we use as developers that help keep our code beautified, but we'll get into that more later. We access these objects using dot notation and bracket notation. Dot notation is the more common of the two. We access an object's data by using the object's name followed by a period followed by the property name. In bracket notation, the object name is followed directly by square brackets. Inside the square bracket, the property name is specified as a string. We should also note here that nested objects can be accessed by chaining bracket and/or dot references together. Here's an example of an object with nested properties. So what do you say we practice this in the console? Okay, so we are in the console of our Google Chrome browser, and here I have put in the example into our console, and we can play with this information now. So we see at the top here is our empty object. It doesn't have anything in it. And then immediately we redefine person and populate this object with all this information, all these arrays and variables and strings and these methods, which we call them functions, but inside of an object there are methods. So let's play with it and see what we can do using dot notation and bracket notation. So let's check out person.name. And there we go, we get the array, JP Miller. If we just want the first name, we can say person.name 0 is the first item in an array is 0, JP. We can do the same thing with our interests, person.interests If we just do it again, then you get both interests. You can ask for only one of these interests, and there you go, hiking. That's a dot notation, and then using the bracket to get that one piece of the array. We can also run the functions. So let's do person.bio. Now, if we just run it like this, it will show us what the function is. There's our function. So you want it to actually run the function. Let's put this function into use. We add the parentheses, and there we go. JP Miller, he likes improv and hiking. And now, what about greeting? Now, they look different. Do they actually do the same thing? Well, let's test it out. First, we can say person.greeting. And again, we can run it, and we see here's the function greeting. It looks slightly different, but they're both defined as functions. And then we add the parentheses, and hi, I'm JP. Yeah, pretty cool, huh? Okay, let's take a look at our object with nested properties. Here we have our object, our object named object, and it has different properties named baz, foo, and bar. How do we access that, right? So we can say object. Let's start digging into this object. Object.baz. Let's go deeper. Foo. If we go all the way here, we get our return value of 5. That's what we were looking for. So we're digging into these encapsulated properties. Let's use bracket notation now. And same thing. This is quotes now. Right, like that. All right, so let's do this again. Foo, we're getting closer. And then again into bar, and voila, there we are, 5. So you can see, and we can even mix this up. That's right, we can go all the way here, baz, and then we can say foo, and then we can say bar, and it works. Beautiful. So that's how you dig into nested properties, and this is very important to know because you will see this because of encapsulation and because you want to avoid having global functions that just anyone can see. So you will see these examples. Now I want to show you one more thing. You can actually see if you go, you can dig into these. So this object baz, we can dig into baz as an object, foo, and there's bar right there. And you can look at all these things too, and this is everything that's made up that proto-object. Pretty cool, huh? Okay, but moving forward. I also want to note that functions inside of an object are called methods. To put another way, methods are functions stored as object properties, i.e., methods are actions that can be performed on objects. In our first example, the bio and greeting functions are methods. Well, let's take a quick look at that again. The greeting method uses the newer shorthand syntax, but both do the same thing. Object literal notation is useful for creating new objects, but it cannot add properties or methods to existing objects. Fortunately, adding new data to an object is as simple as creating an assignment statement. So let's jump back into the console and let's add a location to our person object. So real quickly, we'll add a new property to our person object. So we'll say person, and let's go ahead and add a location. we'll just say this location equals. There we go. Make a nice detailed array. And there it is. Okay, and now let's test this. Do we have a location in our array? Yeah, we do. There it is. And if we want to take a high-level approach, like this tutorial, there it is, person.location sub 0. Or if we would like to take a low-level approach, we can sub 3 that, and you have the city of Madison. Wonderful. Okay, so now that we understand objects, we can discuss object-oriented programming. The marketing definition of OOP and the one provided by MDN is object-oriented programming uses objects to model real-world things that we want to represent inside our programs and/or provide a simple way to access functionality that would otherwise be hard or impossible to make use of. As we discussed, objects can contain related data and code which represent information about the thing you are trying to model, and functionality or behavior that you want it to have. This introduces us to the concept of encapsulation, which is the idea that object data can be stored inside an object package, aka namespace. Let's return to our first example, what we'll call our person object type, to discuss object-oriented programming. Oftentimes, when we want to understand a complex thing, we will create a simple model as a way of wrapping our brains around the inner workings of a more complex model. It's kind of like creating a styrofoam solar system to grasp the scale of the real one. This is called an abstraction. Unwittingly, we've created an abstraction in our first example of an object. And technically, there are no classes in JavaScript, so try to avoid getting in that argument. But for the sake of abstraction, and because classes are a common concept when talking about object-oriented programming, we will use this term to describe the process of object instantiation through the use of constructor functions. But I'm getting ahead of myself. Okay, so here we have a class. It looks like our original person object, but it's not an object. No, this is a class, a template that defines what properties our objects should have. The class can create endless instances or similar copies of itself. We call these creations object instances. Object instances contain constant data and functionality as defined in the class. From our person class, we are able to create actual people. We call this process instantiation. A side note here, instantiation is enabled through something called a constructor function. We could say we call or run a class's constructor function to instantiate an object instance. This leads us to polymorphism, the ability of multiple object types to implement the same functionality. Let's take classes to a whole nother level. Just like we can create object instances from classes, we can create new classes based on other classes. This allows us to reuse common functionality rather than duplication. The new classes are called child classes. Child classes can inherit the data and code features of their parent class. Specialized features can be defined for differing functionality, right? Because children are not exactly like their parents, right? Now we can create new object instances from our child classes. You often will not know how many objects you'll need to create when building a code base, So object-oriented programming allows us to build scalable code through the use of constructor functions, which we mentioned previously. Constructor functions chain link functionality via a prototype chain. It's not true instantiation in the classical sense, but it is how JavaScript drives functionality between objects. All right, there is a lot more to this, and we'll explore some examples and object prototypes in our next discussion on object-oriented programming. So tomorrow we'll have a quick review of this content and then jump into some examples and learn about the object prototypes that I teased at the very end of this lesson. If you find that your brain isn't oozing out of your ears by the end of the day and you've got to have more, then you can work through my references and practice some of the examples on MDN before we actually do the lecture tomorrow. If you'd like to study the subject a bit more, but would like something a little more passive, then let me suggest Uncle Bob's YouTube videos on solid principles of object-oriented programming. All right, thank you for listening. Any questions?